these, Roman numeral 1, 2, 3 type of questions where possibly only one or more than one are valid answers. And so let's take a look at the question. When the positive integer is x divided by the positive integer y, the quotient is 3 and the remainder is z. When z is divided by y, the remainder is 2. Which of the following could be the value of x? Okay, so the first thing that we need to do is we need to organize our information because there's a lot of confusing information that is going on here. And I would say, let's start with our question, right? Which of the following could be the value of x? Okay, so we're going to take a look at x and see what do we know about x, right? So positive integer x, when x is divided by y, then you get 3 remainder z, right? Okay, so let's take a look at what our possible values, right? Remember that x and y are both positive integers, okay? That's going to be important. So, for example, if you take, x, y, and z, and you make a chart, right? Well, x, which of these are possible values for x? So x could be 5, it could be 8, or it could be 32. Now we want to see which, if any of the, right, which of these give us valid results based on all the information in the question. So x divided by y gives us a quotient of 3. So what positive integer y could I divide 5 by in order to get a quotient of 3? For example, if I divide it by 1, I get quotient of 5. So that's no good. If I divide it by 2, I get a quotient of 2. Notice that we skipped over 3. That means that, if I keep going bigger with y, then the quotient is just going to keep getting smaller. And therefore there's no possible values where that y could be in order to make the quotient 3, because we skip over 3 from quotient 5 to quotient 2. So 5 is not going to be a possible answer. And we'll see that the same thing happens with 8, right? 1, if we divide by 1, we get a quotient of 8. If we divide by 2, we get a quotient of 4. And if we divide by 3, we get a quotient of 2, right? And so, right, regardless of the fact that dividing by 1, 2, or 3, dividing by 1, 2, or 3, you get, quotients of 8, 4, and 2. So you skip over 3 from 4 to 2, which means that there's no possible integer values, y, that gives us a quotient of 3. So at this point, I look at my answers, and I've eliminated 1 and 2, 1 and 2, and so my only possible answer is C. So C must be the right answer. But let's imagine that they gave us another option, which was none of the above. And so I need to determine whether Roman numeral 3 is valid or whether none of the above are valid. So the way that I would do this is I would figure out, okay, well, what numbers can I divide 32 by in order to get a quotient of 3, right? And it's going to be, 9 gives us a quotient of 3, and 10 also gives us a quotient of 3, right? So those are, if I divide by 8, it'll give us a quotient of 4. If I divide by 11, it'll give us a quotient of 2. So what are our remainders for z? Well, in the case of 9, it would be remainder 5, and in the case of 10, it would be remainder 2. So now what I could do is I could go to the second part and see when z is divided by y, the remainder is 2. So I take z divided by y, 5 divided by 9, gives me 0, remainder 5. So that would not be a valid number. But when I divide 2 by 10, that would give me 0, remainder 2. So quotient 0, remainder 2. And that's exactly what I need, is that remainder 2. So this, in the case that there was a none of the above type of option, this would confirm that Roman numeral 3 is, in fact, could be the value of x.